Okay. Public. One viewer. Hello, Zero Mr. T. So you're my only viewer tonight. Um, there we go. We got Priceless PPP, Sora Cloud, Aaron 929, Priceless. Yeah. James Leatherwood. Hey guys. So this is going to be another test of the live streaming telescope software, and so once again, gonna just run through this and see if we run into any problems. Um, and then we will hopefully move to a sort of the bigger plan where I invite guests and we look at telescopes and I let people who are stoked. Is that yeah, so people who want to try astronomy for the first time can actually do this, and so we've actually got this telescope is set up to be able to do that. People are gonna be beep booping me. I've sent out a bunch of messages. I'm gonna try to get a guest tonight, but we'll see. It's sort of last minute. Um, I changed the video resolution. Resolution is which is not supported. Okay. Expected video is 2560 by 1440. Why? Okay. I'm gonna have to stop my stream for a second here. 2560 by 1440. See what happens. Yeah, okay, I gotta stop the stream. I might have to come back. Okay. So see if that fixes the issue. It says poor right now. Let me know if you guys see any drops or problems. So right now the telescope is outside my on my patio outside. It is pointing at Polaris, and it's not pointing exactly at Polaris. You can see that star there in the field in the upper left. That is Polaris. And so what you want is it to be dead in the middle. That is perfectly polar aligned. But this is the best I can do. Um, I can't get it to polar line any closer than this. I mean, I probably could, but it would just take me all night. And this is a tiny little drift off of polar alignment. So then, what I want to do is sort of we'll look at some objects together. And so the way this works is that this is a home built smart telescope. So it's like the Sea Stars, like the Vespera, the Unistellar, the Dwarf Mini, like there's all of these smart telescopes. And I ran into all kinds of problems with the smart telescopes. And so instead, I rolled my own. And that's what this is. So it does the same stuff that the smart telescopes do. It plate solves on the sky, so it knows where it is, knows what it's looking at. It's then able to move to any target that is visible in the sky right now. And then when I click on the imaging button, it will start to take images of the sky and then stack them up in real time, removing or sort of improving the quality of the picture frame by frame by frame. And it does a bunch of other tricks as well. It will remove satellite trails, but I want them to kind of sting. So what will happen is we will see the satellite trail come through for one frame, and then it'll remove that satellite trail again for the next frame. So just keep an eye on that. Yeah. So let's yeah, this is all like vibe coded and sort of built to my exact spec. So it is not a public sourced technology stack. I'd be happy to let other people extend it and modify it and do whatever they want with it, but right now it's just a jagged mess. I don't think anybody wants to touch with a 10-foot pole. So this is just to hopefully give people a chance who've never used telescopes before a chance to actually use a telescope. So the specs of the rig are actually there on the screen just below my picture. So it's a Stellarvue SV70T with a ZWO camera and a ZWO mount. Oh, and I don't have I've got a focuser on it as well now. All right, so I'll just show you. Let's go somewhere. So what's cool is I have a different app. So hopefully, and I haven't tested this live yet, so we're going to find out if this works. It should switch to a constellation view of the sky when the telescope is skewing to a new location. So we'll see if this works. So let's just start with M13, which is the Great Globular Cluster in Hercules, and it's my favorite. So now I've picked it as a target, and so now it's going to slew. And so now you can see what the target is, where it's going to be going to. You can see Hercules, and you can see the telescope is moving to the position. It's too bad I've got to sort of do a hybrid model because I can see the stars sort of streaking, but uh-oh, is there a cloud? Let's see what happens. There are some clouds up there tonight, so... Oh, no, there it is. Okay, great. So we're in the live mode. So this is... it's taking half-second exposures and then just replacing them one after the other. So now I'm going to do a 10-second exposure. Not 100. 10. Yeah, okay. And then I'm going to start the imaging. So what this will do now is that this will take a 10-second exposure and then put it on the screen. So there you go. That's 10 seconds. So you see we went from a half second to 10 seconds, and it's much better. And then, of course, my info card is overwritten here. The finest globular cluster in the Fraser's picture. That's pretty small. Does that get better? No. I need a... Okay, I'll fix that. See, I'll make me smaller. I don't need this so big. Okay. I'll sort out the shapes and sizes of this later. So now we're up to 5 frames. So we've been recording for 50 seconds. And so each frame gets a little bit better as we add a little more data that would sort of make it just improve the view of from the telescope. So there's another cool thing here, which is that I'm sharing every image that we're taking. Oh, right, I haven't saved it yet. Okay, all right. Well, as soon as I save this image, then I'll give you a Google Drive link that will let you access any of the images that I've taken. You can download them. You can stack the data yourself if you want. If you want to start learning how to stack data, it's all the raw FITS files. So James Leather was asking, is it better to have multiple 10-second exposures or fewer longer exposures, or just more about the total photons collected? Yeah, so it's more about the total photons collected. I showed at the beginning how the telescope isn't perfectly aligned to the North Pole, to Polaris. And so this telescope will drift a tiny little bit on long exposures, but 30-second exposures are totally fine. So I'll just show you. We'll do another version and we'll do a 30-second exposure. So this is now, we're 13 frames, over 2 minutes of integration time. So I'll stop the collection. Future path. No, this was totally random. I'm still kind of in testing mode. So I got clear skies, and so I'm testing. And so then we'll go back to live. Okay. And so So that's the live view again, where it's just doing, oh, we're at 2-second exposures. That's weird. Okay, that's a bug. It should be at 50-second exposures. 0.5 second. Okay, so now I'll do a 30-second exposure, and you'll see what you get is a big jump. Like, it goes from the part where you can barely see it to the really nice version, but it takes 30 seconds. So I like the 10-second exposures just because you get something right away, and then it just gets better and better and better. So now, right, we're waiting for 30 seconds for that first frame to come in. And it should be giving the... What if I'm hiding it? Okay. Okay, so AEF Fish, please explain how you got everything to talk to each other. Yeah, so the nice thing about the all of the ZWO stuff is all kind of talks together, and they've got a really good API to be able to connect to all of their devices. So I've got a Mac Mini that has the focuser, the mount, and the camera all connected to the computer, and so it's able to control all of the different bits and pieces, and then it's got this layer on top of it where it's operating the actual telescope. So you see how it got markedly better on that second frame. And so this is what a 30-second exposure looks like compared to the 10-second exposures. And if you see, like, over on the right-hand side of that, there's a little tiny galaxy. I don't know if you can see it, but there is a little, and I forget the designation of that galaxy. So, yeah, there can be more noise. So there's like a light layer of clouds right now. And so the way this thing works is that if you get, so that's 3 frames now. And, normally you go for, I don't know, 10 minutes, 20 minutes, but I'm only doing like a minute here and a minute there because we got lots of objects to look at. So I'm going to stop this guy and let's go to something else. So let's go. Okay, so let's go to, say, oops. Yeah, okay, so, sorry. Okay, let's see if this works. Nope, that doesn't work. Okay. Oh, getting a backup error. Okay, I can't back them up. I can't share this with you. Okay, no problem. Another error to fix. All right, so let's look at a galaxy. And let's go for something big. Okay, we'll do M101. This is nice. So now it should show you Ursa Major, and then if you know the Big Dipper, this is the location of M101 in Ursa Major. And this is the real speed of the telescope. So you're seeing the telescope move and what it's doing. So the way the algorithm works to actually control the telescope is that it gets close and then resolves again to try and put the object dead center in the middle of it. So it actually does 2 moves to get to a place where it can actually show it. Yeah. No, this setup is terrible for planets. It's good for the moon, and I've got a totally separate moon algorithm that I use. Totally changes the exposures, and it actually tracks the moon by keeping the circle of the moon in the middle of the frame. And the next plan is to come up with a system for all right, let's start imaging. I don't even see the galaxy in there. Okay. And then the next plan is to figure out a way to do planets with this setup. But they're always going to be terrible just because it's a really wide field of view. And so it can't see little things. And planets are actually really, really small compared to a lot of the deep sky objects that are out there. Oh, I should have gone to 10 seconds again. So in theory, there's a galaxy in the middle of that picture. But we can't see it yet because it's only a half-second exposure. But when the first 30-second exposure comes in, there we go. So now you can see the galaxy. So that is M101, the Pinwheel Galaxy. A huge face-on spiral in Ursa Major with sprawling asymmetric arms about 21 million light years away, nearly twice the width of the Milky Way. It's dotted with vast star-forming regions. So yeah, so I've got text explaining these things. Got the constellation view, so you can actually see the telescope moving to its position. Yeah. So this is rock solid so far tonight, except for a couple of issues. Yeah, good. I'm glad you guys like the description coming up. I got to change the shape of it, but so it'll be a little bit wider. And so this is all the software that I'm using to control the telescope puts out bits and pieces that I can then put into the software that I'm using to stream the telescope view with. Yeah, the reveal is cool. Like that first 30-second frame is nice. Then now at this point, the improvement on the data is minor, and it's still pretty bright outside right now. Like it's not dark because I live in Canada, and June 21st is the solstice, and so I'm only about a week and a half past the solstice. So we actually don't get any pure sky darkness right now. It gets to like 99% darkness, and then it comes back to the light in the morning. It gets dark here around 11 and gets bright around 4. So yeah, we don't have a lot of darkness. Is there a way to filter the blue out? Well, so the blue is just the background of the sky, so it's still a little bit daytime. So the way we filter out the blue is wait for the sky to get darker, and these are the conditions that you have to face when you're doing astronomy, and especially starting so early. So I'm going to stop this image. And then let me see if I can get a... Okay. So let me see if I can get a comment. That's pretty bright. Okay. C 2023 Pan Stars. Let's see if we can get it. Brian drawn, my scope is always looking at me from across the room, and I feel guilty for not having it outside. Yeah. I mean, telescopes will turn into laundry racks if you're not on it. Okay, so in theory, there is a comet in there. So let's find out. Yeah, see, do a Fraser deep field. Yeah, we could do a deep field, but it would be really boring because it would just be staring at the same spot in the sky for hours and hours and hours. And it's a telescope under the... All right, I'm going to go to 10 seconds to see if we can even see anything. All right, so we see. So we're under the Earth's atmosphere, and so telescopes can't do very long exposures under the atmosphere without adaptive optics. Yeah, so now I'm on 10-second exposures. So this should come in much more quickly. Is that it over on the bottom corner? Huh. Like I see something just peeking out from the bottom. I have no way to get that. Yeah. Okay, let me see if I can find the exact right ascension declination of it, because my system is clearly late. Doesn't have it exactly. I can slew with air. Okay, let's do that. All right, hold on. Let's try this. So, wrong way. Okay. I don't think it's the comet. I think it's a star. Okay, let's try this. So we'll do a 10-second. Yeah, there is a manual control. Boom. Yeah, so that was just a star. So that is not a comet there. But the magnitude is only 5.5, so it's like almost visible with the unaided eye. So unless this is a comet, but I think this is just a star. So hopefully that trail, that satellite trail should be removed. But maybe that's not working either. Is there a tail? Huh. Yeah, I think that is a star. That is a comet. And let me see what other people's pictures of it look like. 2020. Yeah, magnitude 5.5 is really bright. C 2023 R1 pan stars. Yeah, okay, that's it. That is the comet. I'm looking at the Sky Live, and they've got a shot of it that someone took. Huh. Okay. I guess that's a comet. All right, let's move on. Let's do a nebula. So I'll stop the image. Let's do the Lagoon Nebula. It's funny to see the satellites, all the satellites now. There's so many satellites that are passing through the field of view. So there's Sagittarius, and you can see it looks like a teapot. That's how you can know, and it totally looks like a teapot if you know where Sagittarius is. So this is a very low object, but I got it last night, so I think we can do it again tonight. It's still slewing. Okay, now we're near the area. And then it does a little fix, and it should go dead center. Yeah. There we go. This is cool. Lagoon Nebula is great. Let's see. 10 seconds. It looks good. Like I did about an 8-minute exposure of it last night. It was really nice. There we go. and still not very dark. So hopefully this will get better. So that's 30 seconds. Yeah, this is close to the center of the galaxy. So the supermassive black hole at the center of the Milky Way is in the Sagittarius constellation. Cool. Awesome. And then, oh, we got a little bit of trailing there. So you can see some of the stars are like a little bit curved. So that means that that the mount got bumped or there was wind or something like that. And so normally if you were actually producing images, you'd throw out that frame, the one that's causing all of the star trailing. Yeah, that is garbage. All right, so let me stop. And I'll do a 30-second. And we'll see if that works. Aaron, do you personally believe in a Planet 9? I don't have any opinion about Planet 9. Some astronomers have calculated it's there. Others disagree. Vera Rubin is rolling now and should give us the answer. It's weird. The 10-second one does show the stacking, but the 30-second one doesn't. Okay, another bug. I should be writing these down. So that's a 30-second exposure in one go. And so you can see, now you can sort of see. So we did the 10-second exposure before, and now with the 30-second exposure, you see there's like a lot more noise in this picture, a lot more. It's almost like the background of the sky is a lot brighter. But when you get the next 30-second exposure in there, then a lot of that background brightness will darken. There, you can see it darken. So this is the same experience. If you have a a smart telescope, if you're like looking at your sea star on your phone, this is kind of what you're seeing. No, the longer exposures aren't harder to stack. So the reason, like, I could do a 5-minute exposure. I could try that. It would be very boring while we sat and waited for the telescope to do a longer exposure. What you're looking for is that you don't want it to get star trailing. So, the telescope isn't perfectly polar aligned, which means that the telescope is trying to track what it thinks is the position of the stars, but it's a little bit off. And so over a long time, you'll get this little bit of star trailing because the telescope is a little misaligned. So that looks pretty great, though. That's a great... So let's do the Eagle Nebula next. We'll let this fourth frame come in. Do an impromptu QA. You can always do an impromptu QA. No problem. Yeah, the stacking does align. So if I do 30-second exposures or 10-second exposures, then even if the telescope is drifting, the stacking lines up all of the pictures on top of each other perfectly. But it's that if it's a really long exposure, then you're going to get a little bit of star. You know what? Like, I don't want to. We're just going to do it. So I'm going to do a 300-second exposure. Stephen Yevon, do you sleep? Not lately. I am not a good telescope person. All right, let's do 180 second. Okay, let's see if we can pull off a 180 second exposure. So this is going to be a long one. So I'm going to have to sort of fill the time while we wait for the telescope to grab 180 seconds. So the part that sucks about astronomy for me is that it's at night, and I am not a night person. I'm a morning person. I'm a day person, and so no matter what time I go to bed at night, I wake up around 5, 6 in the morning. Also being an old man uh, is part of that, and so I've been, the only time I'm able to do this testing is in the middle, late at night. And so I've been staying up till like 1 or 2 in the morning trying to make this all go. And then I'm like the next day waking up, trying to sleep in, totally bleary eyed and stumbling through the rest of the day. But I've got it set so it can just go all night. It can just record images automatically all night long. And get rained on. So I have to be careful. I'm going to actually, when we're done, I'm going to leave that and just let it just keep recording all night. So next, when are you going to hook this up to look at events from the Vera Rubin data? That'd be cool. That would be relatively straightforward to do, that we could find events that are happening and then follow up with them with the telescope. The problem is the kinds of things that Vera Rubin can see are just too faint for this telescope to be able to pick up. So this telescope could probably, on a good night, see something that's maybe 12th magnitude, 12th magnitude. And Vera Rubin is turning up supernovae at 15th magnitude in galaxies. So like the best we're going to do is a supernova in a, we're just gonna see a picture of a galaxy and know that there's probably a supernova in there. So, Vera Rubin is directed at the southern sky, but there's tons of overlap. So it goes, and I forget how far up to the north it goes. So, like Vera Rubin can see Sagittarius in the same way that we can see Sagittarius. It's not like there are two different skies. There is an overlap depending on how far south you are. People in the south can't see the Big Dipper, but they can see some of the constellations that are lower in the sky for us. So, Ed Skeptic, what is the highest magnitude ever seen? I think the Hubble Space Telescope can see magnitude 29, and that's about the limit. And I think like the Gaia mission was doing 25. I'm sure James Webb can see something in that same kind of range. Yeah. James Leatherwood, when will artificial star laser telescopes be available for the general consumer market, or is there something available already? So the adaptive optics is a pretty big piece of technology. You've got this laser that's firing out of your telescope. You've got the mirror adapting in real time to switch to the shape of the distortions of the atmosphere. So really, they only install them on the biggest telescopes in the world, like the 8-meter telescopes. So there is 180 second exposure. And so that's a 3-minute exposure. And so that is definitely the star trailing. And so you can see all of the stars are like little lines. And that's because the telescope isn't perfectly aligned. And so for 180 seconds, that little slight out of alignment adds up, and then you get this problem. Oh, there you go. James Webb limiting magnitude of 34. Okay. So that's why I don't do 180 second exposure. And so if we do another 180 second exposure, we're going to get kind of the same thing again. 30 seconds, very safe. 60 seconds is probably safe on this telescope, but I wouldn't go beyond 30. So, but doing short exposures, 10-second exposures, perfectly fine. Stack them up, boom, 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 and you sort of get the data, over time. And so a lot of the times, like if I was going to take like a really long picture, like I could set this telescope at one target and have it just track that target all night long. And it would do, 5 hours of 30-second exposures. And that would be really nice. Like that would be a really, really good picture. God, do I even want to wait? All right, we're going to wait another 90 seconds or so for the next exposure. And now you will have experienced what happens with longer exposures beyond about a minute. So I'll probably stay in the 30-second range or even 15 seconds. Depends on the object. You know, some of these objects like the star clusters, globular clusters, you can dial them in with 15 seconds with this telescope. And so speed is the key. We can just go fast, fast, fast. All right, but another 45 seconds and we'll be done. 1,000 dots. Is there any advantage of very long exposures over stacked shorter ones? Yeah, it's just like you want to do the longest exposures that you can get away with, because then you get more photons collected into your camera, but not so long that you start to get star trailing. That is that's the balance that you're always trying to do. And even like, with the Hubble Space Telescope, James Webb, they don't drift at all. And so they can take really long exposures, but they usually don't. Like they will often take 5-minute exposures, and then the astronomers will stack up all the exposures, because again, if you get a satellite pass through the field of view, then you might lose a big chunk of that stack. Yeah, 30-day Hubble exposure. Is it done? Okay, so there's the second frame is in, and it's coming along, but I'm gonna stop it now. So that is that experience. What else we got? So let's try the owl cluster. It's not sweeping out back to the live view. Okay. What? Okay. Is the camera locked on this? Wow, didn't like the 3-minute exposure. It's weird that it's slewing and it's not showing you. So let me see if I can look at the pictures that we took earlier tonight. So we took this picture at the beginning of the night, which is the Great Globular Cluster in Hercules. And then we took this picture, which is the M101 galaxy. No, it is definitely not happy. Okay. Let's see the status of that. Okay, I'm just going to shut the telescope down and start it back up again, because it is clearly locked. So let's see what happens. So when I shut it down, it disconnects the camera, disconnects the mount, parks the telescope so it's pointing at the North Pole. Oh, are we still sharing that? That's weird. Okay, so let me start up the telescope again. Yeah, whack on it. Okay, so there's Polaris again. And again, so you see, um, it's not it if this telescope was perfectly polar aligned, then Polaris would be right in the very middle of the sky. And so now it has to go through this process where it, like the startup procedure, it goes to Polaris and then moves to an opposite part of the sky, plate solves to try and figure out what its orientation is, and then comes back to Polaris, and then it does its autofocus sequence to get the camera focused, and then it and then moves on. So we're just in the focusing step right now. Yeah, it's halfway through the focus. And then we'll go, yeah, the Dumbbell Nebula. It sounds great. We'll do that. Okay, so it's done. It's got its focus. It should be back at Polaris. Or it's going to move back to Polaris. So it's moving through all the different constellations. This is cool. Okay, so now we're back at the North Pole. All right, so let's do M27. Yeah, it's very high. It's good. Hey, Mr. Rex. So there's the Dumbbell Nebula. And then we'll do and I'm going to change the exposure length back down to, let's do 15 seconds. Yeah, I can see it in there. I don't know if you can see the dumbbell in there. This is great. I love it. Oh, there goes the satellite. All right, let's start imaging. Pleiades aren't up right now. So we'll do 15-second exposures now. There we go. Cool. So this is a planetary nebula, which is a dead star like the sun once was. And then it died and puffed out its outer layers into space. And all the different planetary nebulae look different. And so each one is its own special creature. And this is probably the biggest, sort of most well-known one. So, yeah. And so, boom, here we are. And so we don't need long, right? What, 45 seconds? We haven't even done a minute yet of this. So we'll go and see all the planetary nebulae that are up tonight. Let's see how many we can get. Dark nebulae. Okay. Oh, there's 130. All right, all the good ones. All right. And so a part of this that's kind of fun for me is that I don't know what's good or what's bad. I have a database of all of the things that you can look at, but I don't know what the good things are and what the bad things are. So, but the dumbbell is the best. So everything is going to be a pale shadow of the dumbbell. But let's try another planetary nebula. We'll sort them by magnitude, or we'll sort them by size. Okay, so let's try the Owl Nebula next. And I have never tried to look at the Owl Nebula before. And, I'm sure you've seen a picture of it in, the Hubble Space Telescope. So this won't compare to that, but we should see it. Um, Relnet, could you do live tiling so it would keep all the captures that you made in the hemisphere? Probably, yeah. So we would just keep all of the pictures that we took in an area of the sky. It's about a half degree. The sort of the size of the telescope is a little bigger than the moon. It's more like a degree actually. So I could take pictures all the way around. I forget how many degrees there are in the sky, like 20,000 or something. Still says that it's slewing. All right, so we're live, and I don't see anything there. So let's take a picture. And so this tells me, this makes me think there's clouds. No, you know what? This tells me it's my house. Yeah. Yeah, that's no good. Okay, we can't do the Owl Nebula. 39 degrees to the northwest. For sure, my house is in the way. So let's try the Snowball Nebula. Okay. Yeah. The, the House Nebula. So it was probably trying to solve the stars, but it couldn't see any stars because of my house. And so now it can see stars again. It should be. The moon is not up yet. The moon will be up in another 2 hours or so. All right, so let's start the image. Are there any planets up? Let's find out. I mean, none of the good ones are up right now. So just some, like maybe we'll get a Neptune or a, let me see. Nothing. Nope. So do you see the blue snowball there in the middle? Yeah, when does the moon rise? Moon rises at 12:30 and it's 55%. But it won't be, let's see, when will it get above the horizon for me? 3 degrees, 4 degrees, 6 degrees. So it won't be visible until about 1:30 a.m. Yeah. Western Veil? Sure. Let's do the Western Veil. All right. So there you go. That's the blue snowball. So this is the kind of thing that I would want to record for, say, 2 hours on to get. But you can see already now that the sky is getting darker, you see how the sky is a lot blacker now than it was before. All right, let's do the Western Veil. That's a good nebula. And that is 45 degrees to the east. Okay. This is great nebula. So this is a chunk of a supernova remnant. So I forget how long ago, but 6,000 years ago, a star went supernova in the sky and threw out this debris, and the nebula is gigantic. So it's actually like a huge ring that you can build up. And this is just one chunk of it. You should be able to see this sort of faint wisp that's going through. And then there's the eastern veil, the western veil, and there's a couple more parts to it. And so some people will take a gigantic mosaic of the entire object and make it, and so you can see the full explosion. It's huge though. Now keep in mind, like this telescope is like you could fit 4 moons in this frame. I need a way to zoom in. So yeah. But yeah, so no planets tonight. I mean, some will probably rise at some point in the night, but none are up right now. I mean, not even Neptune or Uranus. Everything's down. So that bluish filament is the debris from the supernova, and it's this expanding cloud. It just happens to be passing near a star in the sky right now. 1,000 dots. Does anything come out of a supernova that is solid enough to become an interstellar object? No, you get dust is the main thing. Supernova are the manufacturers of dust. Yeah, so when you see the streaks going through the image, those are satellites. And so there are tons of algorithms that'll remove satellites from your images. And so we've got this, but it's not great at removing them. So what I want to have happen is we'll take a picture. Okay, we got 2 satellites that passed through the field of view so far. So it counts the number of satellites that have gone through the view. And so what I want is you'll see the satellite trail, and then we can all wince at it and go, oh, satellite. And then the next frame, it gets removed because it just runs the algorithm to remove the satellite from the field of view. But only the bright satellites are easy to move. The faint ones are harder to catch. So that's the eastern veil, and so why don't we do the western veil? And so this looks good. Like this is 2.5 minutes. So this really isn't enough time. Like to make this look good, it needs to be 10 minutes. But we don't have time for that. So let's go to the eastern veil. So the eastern veil is very close. So we don't have to go very far. But because it's doing this plate solving, it finds the target, moves a little bit over, checks to make sure, and then zeroes it in right at the center of its screen. So we'll take a picture of the Eastern Veil Nebula. Mr. Rex, Fraser, what college did you go to? I went to the University of British Columbia for engineering back in 1989. And then I went to North Island College for computer science. So my degree is in computer science, not in engineering or astronomy. There we go. And that's still amazing, right? A 15-second exposure. Just boom. There's the nebula. We can see it already. So it's very fast. Yeah, Eagle Nebula should be really nice. So we'll go do the Eagle Nebula. James Leatherwood, do you have any plans on acquiring and integrating a planetary scope as a scope that is good for planets? Yeah, absolutely. So what I want to do is put a second telescope on this same mount, and so the mount can carry both telescopes, the deep sky telescope and the planetary telescope. So I just need to get my hands on a planetary scope, and then you put them on like a fork, so both telescopes are lined up like a double-barreled shotgun, and then I can just switch back and forth between the planetary scope and the deep sky scope. So there's the Eastern Veil, and again, like this is one minute, so it's not going to look as good as it would look in 10 minutes. So let's do we'll do Eagle, and it looks great. And it's nice and high. Well, 23 degrees. But I have good view to the south. Aaron, where can we donate specifically for that scope? It'll happen. Like I'm still testing and getting this telescope working. So, once this telescope's working and everything settles down and it's dependably pointing at the targets that I want it to point at, then I'll figure out how to put on the second telescope. Or maybe I just put it on its own separate mount. The mount is really strong though. It can handle like way more weight than I've got on it right now. Jamie Ball, how is the light pollution at your location? What's your Bortle level? So my Bortle level is 3. So the light pollution is not bad. I can see the Milky Way. It's pretty good. All right, so let's do the Eagle. Skeptic, when can we book some telescope time? Check out Starfront. So Starfront has C-Star telescopes that you can rent time on and take pictures like this. So there you go. There is the Eagle Nebula. And right at the very center are the pillars of creation. You still time on it to pay for itself. Yeah, I mean, I just don't get enough dark skies, so that would suck. Like, this is the last clear night that I'm going to get for probably 10 days. Oh, there you go. Narf says their dark sky site is Bortle 3. Oh, and we got a nice satellite trail right through. And so you see the oh, you don't see it. Oh, okay. My interface shows how many satellites it's removed. And it looks like it was too faint, so it wasn't able to remove that satellite. Let's do another galaxy. And like a really nice star cluster. Let's see. What would you do? NGC 5866. What is that? Oh, that's cool. A spindle. Okay, let's do that. Okay. Can we see this? West-northwest. But it's, yeah, so it should be above my house. James Leatherwood, the upcoming Super El Nino is going to suck for your viewability late this year. Yeah, we get pretty bad rain starting. Like normally we get nice clear skies all through the summer. It's been pretty cloudy so far. And then we get our rain arrives in September, October, and then it just rains every day for 6 months. All right, so let's see if we can get the Spindle Galaxy. This is cool. I've never taken a picture of this before, so I'm kind of excited. The Seifert's Sextet. I don't know. Yeah, we can do that if you want. We'll see how this one. Let's see how the Spindle Galaxy comes together, and then we'll do the Seifert's Sextet. So there's the galaxy in the middle. It's teeny tiny. So if I was like doing this for real, I would do like a really, really long exposure, and then I would just clip that little part of it. I don't think the sombrero is up right now. Nope. It's 3 degrees above the horizon, so I can't get it. 50 million light years away. Edge on lenticular galaxy. That's cool. Oh, satellite. Let's see if it can remove it. Removed! Nice! Haha! That is awesome. Mr. Rex, you have a telescope you're watching this. Is this a website you're showing us? This is a telescope that's just outside my door. I'm controlling this telescope right now. And so the software allows me to live stream from the telescope onto YouTube. Okay, that's cool. It's not going to get a lot better. So we'll stop that one. All right, we'll try the Seifert's Sextet. I've never done this either. 2.8 arc minutes. So it's going to be teeny tiny. Yeah, removing the satellites is very satisfying. So before, originally, I was like, no, I want you guys to suffer. I want you to feel and just get angry at all of the satellite mega constellations. And now I was like, there's too many. So we removed them. So I have no idea. 2.8 arc minutes is very, very small. So my guess is this is just going to be a little tiny blob of fuzziness in the middle of the screen. But we'll see. One, two, three, four, five. Would enough stacking remove the satellite trails, or would it require too many stacks? Yeah, it would remove. So over time, as you get more data, then the satellite trails are perceived as noise, and they would fade away after enough stacks. But instead, what most people who are doing astrophotography do is they just take the bad frame, the one that had the satellite trail, and they throw it away. And what we're doing is we are removing just essentially the trail itself from the picture. So I think you can see it there at the middle of the telescope. Let's see what it looks like. What it's supposed to look like. Yeah, well, there you go. We've got it. Nailed it. Dimension VG. I am sufficiently mad because I understand how little of the sky you're seeing, and the frequency of the satellites is shocking. Oh yeah. Like, I'm definitely not interested in seeing any more of these satellites. All right, so let's stop the image because clearly, like, it's It's a tiny little fuzzy bit there in the very middle. That's boring. Let's just do a nice open cluster. NGC 6743. Now, if these pictures replicate the view through about a 10 or 12-inch scope. Yeah, I mean, it sort of depends on the brightness of the object. So in a 10-inch or 12-inch scope, like we'll look at the Ring Nebula, and that'll feel very familiar for what it looks like to look through a telescope. But some of the fainter stuff, you just can't see it. Like you can't see the spiral structure of a galaxy, even in a 12-inch telescope. You can see you can see the fuzzy bit where the galaxy is, but you just don't get that structure in it. Tadpole, is there any library that lets you avoid exposures that would contain satellites? No. So this is a star cluster. Just a regular old open star cluster. And I really like star clusters. They're they're different collections of stars in different directions, but they're nice and they're quick to make. I took some. Let me see if I can share one that I took a couple of nights ago. Like this. So that's 7082, and I like that. Lots of super bright stars. There's a little bit of haze in the sky, and so that made the stars kind of big and blobby. But and then here's another one where there's even more haze. So again, big and blobby. Here's another star cluster. Clearly, I'm relying on the big and blobbiness of them with the haze. That's cool. Okay, and so this is the one that we're doing right now, and that's gonna require more time. Yeah, meh. That's a boring cluster. Okay, I'm gonna stop that one. JB Ball, is this the entire field of view, or is the image cropped for streaming on YouTube? It's the entire field of view. Okay. I'm going to do one more picture, and then I think it's bedtime. See what else we got. Let's try M56. Which is another globular cluster. Oh, and I want to show the Ring Nebula. All right, we'll do that too. Yeah, so the resolution of the camera is 1,500 pixels by 1,500 pixels. And that's exactly what I'm showing you. That is the exact sensor that's just the camera. That's good. And then we'll go to the Ring Nebula, which is very close in the constellation of Lyra. Go Lyra Games. What software are you using to be able to control the telescope remotely? It's Scratch built. So it's a thing that I cobbled together from it's Python. It's got an HTML interface, and then it's using all the different APIs to connect to all the different parts of the telescope. All right. I see the cluster there. Yeah, that's right. James, we all voted square last time. Yeah, so last time I was trying to show it in a widescreen view, and and everyone was like, no, the square one is better, and that was good because I was constantly having to sort of change the perspective of it depending on how the object was aligned in the view. So this is the right way to go. Stephen Yemen, are Earth-based telescopes affected by earthquakes like in California? Sure, yeah. If there's an earthquake going while the telescope is gathering data, then you're going to get shakes in the telescope image. Okay, I've had enough of this. Let's move to the Ring Nebula. That's a very tiny globular cluster. Does not compare to. Yeah, all right. So what I need to figure out is a way to zoom in on the live view or no, on the stacked view if the object is very small. Linux, you're basically binning 2x2. I don't think I'm doing any binning. I'm just, the OBS, like it's just a 1500 pixel image. I don't think I'm doing any binning. I hope not. Now I'm worried. All right, there's the Ring Nebula. Yeah, so I want to I should put a way so I can zoom in just to show the detail. Like it'll be very pixelated to show the thing, but yeah. Aaron, could you run code on this to spot transit stuff in the solar system? So I can pull live data from other sources. And so if there was a transit that was going on, I could pull that into into the telescope and then be positioned at the right place to be able to view it. Yeah. So there you go. There's the Ring Nebula. 15 seconds. Boom. And that's pretty much what it looks like to look through a big telescope, like a 10-inch telescope or a 12-inch telescope. That I totally agree. But yeah, I need to make this bigger. I can just, let's see, I can do this. No, not that. Yeah, okay. I'll just do this. Let's go bigger. Let's see how that comes together now. 1000 dots. Is that similar to the Lagoon Nebula? No. The Lagoon Nebula is an emission nebula, so it's like a star-forming region, and the Ring Nebula is a planetary nebula, so it's a dying star. Yeah, so I need a zoom button or like a reframe button so that it just so I guess this is back to your preferences. So would you prefer, yeah, I shouldn't be making these decisions for you. Would you prefer that we just show the actual size? Right, so it's going to be, come on, it's close. Let's say that. So that's the actual size of it in the telescope. And so for like really big objects, it'll fill the whole field of view. Like the Andromeda Nebula the Andromeda Galaxy is bigger than the telescope view. But with really tiny objects, I'm going to need to zoom them in. So do you want me to be able to zoom in on the object? Zoom. All right. Okay. Let's see. let me see what else. Why not both? Yeah, so I think the picture in picture is kind of a good idea. Huh. So where would we put the picture in picture? Yeah. Yeah, so we could put the picture in picture up in the corner that shows the zoomed in version of just the object that we're looking at. Yeah. Yeah, that's good. That's a good idea. And then we just flip back and forth, right? Because it'll be like we're not actually changing the picture itself. We're just flipping back and forth. Yeah, I like that. There you go. So John is looking at the Trifid Nebula. I'll do the same. All right, we'll stop this guy. $17 in the south. Yeah, this should be fine. How do you like the C-Star 30 Pro? I've got the S50 and I like it a lot. So it's sort of strange to me that they made the C-Star they made it the Pro version the smaller lens. So the lens on this telescope is a 70 millimeter lens. There you go. Yeah, the C-Star, like if people want a recommendation for a smart telescope, like kind of like what I'm doing, the C-Star is the way to go. That's by far my favorite. So there you go. There's the Trifid that that John D is working on right now. So now we're having a Trifid race. Oh, we got a satellite trail in the upper corner. Gone. Ha. That's cool. What is a Trifid? Well, like the Trifids, don't those come from the Day of the Triffids book? John, I forget his name. I read it in like elementary school. Yeah. Mr. Rex, Fraser, 55, 54. I'll be 55 in August. Hey, good morning, Zapfan. So you can see the sky is getting a lot darker now, and so it's just a lot nicer. Yeah, and so we already did the lagoon, the Trifid, and the Eagle Nebula. Beastly snippets. There were several short red green lines in the image. What are those? They were all parallel. So there was a satellite trail went through. There could be an airplane going through. Oh, there you go. Trifid means split in three. And so let's see what it looks like bigger. I wonder if I can. Because. How do I get it to get bigger without me having to? Any OBS wizards out there? Zach, can we actually see the Milky Way on the screen? No, because the Milky Way is gigantic. It runs across the entire sky. So right now we're looking at a region that is in the Milky Way, and so there's a lot more stars. Like look at the, well, I guess you can't see it now that I've zoomed it in. Yeah, this sucks. I don't like this. I'm gonna fix this though for sure, because this is a pain. Yeah. Um. Oh, I put together a bunch of descriptions for stuff in the database. I think I copied these from some astronomical listings. But then it's funny because when it's looking at something that doesn't have a like a description, it just says a nebula in the constellation Sagittarius. Yeah, we already did the lagoon. Yeah, I'll work on that tomorrow and see if I can make something that kind of has a nice zoom back and forth or has the picture in picture. That'd be cool. Especially for the things that are like really tiny. Cause then because like that spindle galaxy or even the sombrero, like sombrero is an itty bitty galaxy, but it's such a cool looking galaxy. There's a lot of these kind of things. And but I know the size of the objects. We know that they are like the Trifid Nebula is 228 arc minutes across. And so all we need to do is just have a box that is 40 by 40 arc minutes. And then we zoom into that point. So, yeah. Okay. So it's midnight now. We've been doing this for an hour and 20 minutes. And so I think I am extremely happy with how this went tonight. A couple of problems, like me accidentally trying to image my house. But apart from that, I think this was very successful. So thank you, everyone, for hanging out with me. This is, again, just the beginning. This is the test. The real show will come with when I bring on some guests. So stay tuned for that. Okay, awesome. Thanks, everyone. And what do we got? New question show tomorrow. Maybe an interview on Wednesday. Another question show on Thursday. And then Space Bites on Friday. So we've got lots and lots of good stuff. And so again, this is hiatus. You get to watch me experiment and try things over hiatus. So yeah, awesome. All right. Thanks, everyone. And we'll see you on the next Clear